Let's take a look at some more examples to do with inverse proportion. Question 4 says the number of people who attend a concert varies inversely with the amount of space allocated to each person. If 80 square centimeters is allowed per person, the ground can hold 30,400 people. How many people could attend the concert if only 60 square centimeters was allowed per person? So I drew 2 diagrams just to show you what this actually means. So if a person was given this amount of space, which is like 4 squares, okay, on my iPad, compared to a person who is only given 1 square, okay, you can see that the number of people who can fit in this square would just be 1, whereas the number of people who can fit that same size square, given that the amount of space for each person is less, is going to be 4 people. So as the space goes up, okay, in this case, so the space is bigger in this one, the number of people that is allowed to be in that big square is going down, okay? As the amount of space per person goes down, okay, in this second diagram, the number of people that is allowed in that big entire square is 4 people, which is going upwards. So it's inversely proportional. So we've got to actually make up 2 letters that represent those 2 things. So it says the number of people that are allowed with the amount of space. So I'm just going to use P for people, S for space. So P would equal to K over S, which is our inverse proportionality equation. And we've got to find out what K is first of all. And to find out K, you need to find out 2 things, which is a relationship between P and S. So it says here that if 80 square centimeters allowed per person, then the ground can hold 3,400 people. So 80 represents the amount of space, and 3,400 is the amount of people. So we're going to substitute those 2 things in. So 3,400 equals to K over 80, which means that as I multiply 80 over, I will get my K value as 272,000. Okay, and once I get that K value, I have to put that back into my equation up here. So P would equal to 272,000 over S. Okay. Now the question is, how many people could attend the concert if 60 square centimeters was allowed per person? So this 60 square centimeters is referring to the amount of space, which is the S here. So if I just directly substitute that in, P would equal to 272,000 over 60. So if I divide that by 60 on my calculator, I do get P as 4,533.3 recurring, but you can't have 0.3 of a person. So that means the number of people who could possibly fit in the space would be approximately 4,533. Okay, off to question 7. So Paul believes that at a train station, the number of people waiting on the platform is inversely proportional to the time until the next train arrives. According to his model, when there are 16 people waiting, the train will arrive at 2.5 minutes. Part A. When will the train arrive if there are 5 people waiting? Okay, so some people think that this doesn't actually make any sense at all. Okay, how can the total number of people dictate the amount of time that it takes for a train to come? Well, let me just give you an example. If you're at the train station and you just missed the train, okay, you're just sitting there, you're waiting for the next train, right? Okay, so the amount of people there will be 1 person. Let's just say you're at the train station, you're just 1 person, okay? And when you look on the screen, it says that there is 10 minutes left, okay, to the next train, right? Now, over time, you're going to be waiting for this train. As you're waiting, let's just say now the screen says 5 minutes left. If you look around you in that train station, on that platform, there will be probably, let's just say, for example, 20 people, okay? 20 people, right? And then let's just say maybe there's 1 minute left now, okay? If there's 1 minute left now, then there'll be way more people, wouldn't there? Okay, so the amount of people might be maybe 50 or 60 or 70. Doesn't matter. Okay, I'm just making up numbers. But it might be more and more and more people on that platform. Okay, because more people are arriving to wait for their train. So can you see that the number of people is going up, whereas the amount of time for the train is going down. Okay, this is why this question makes sense. Okay. Now, for part A, let's answer it. We've got to have an equation here. So to have the equation, we need two variables. The two variables that we have to look at are the number of people as well as the time. Okay, so these are the two quantities that are inversely proportional. So we'll say P for people, and that's equal to K over T, which is time. Now, to find out K, we have to substitute in anything we know about P and T, which is our number of people and time. So in the last bit of the sentence, there were 16 people waiting, and the train said that it will arrive in 2.5 minutes. So we're going to substitute these two things in here. Okay, so 16 people will equal to K over 2.5. So then multiplying that 2.5 over 16 times 2.5 will get us 40. And now what I'll do is I'll substitute this back into our original formula. So that our formula to find the number of people will now be 40 over T, but just by replacing K by that 40. Okay. Now, I haven't actually answered the question yet. The question says, where will the train arrive if there are 5 people waiting? So if it's asking for when the train will arrive, you're finding out the value of T. And you're substituting P as number 5 in this case. So 5 equals 40 over T. And if we have a variable on the denominator, we know to switch this number around to the other side. So T is equal to 40 over 5, which is 8 minutes. Okay, so if you count around you, there's 5 people, then the number of, if you count around you and if there's 5 people, the amount of time that it takes for the next train to arrive is 8 minutes. Okay. Question B, how many people are waiting at the station 10 minutes before the train arrives? So in this case, we're given T as 10 minutes, and we're trying to find out how many people there are around waiting. So we substitute that in the formula as T. So P would equal to 40 over 10. Okay, so 40 divided by 10 would be 4. So there's 4 people waiting for a train when there's 10 minutes left. Okay, which means they might have just missed the first train, right?